Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and welcome to this session on controlling project resources. Project resources have a direct bearing on two other project areas, costs and schedule. More the resources employed on a project, less time it will take, but then more will be the costs involved. Hence the importance of this subject. The subject of controlling resources is covered as MEC 10 in your MEC roadmap. We'll cover this subject in two parts as shown on the screen. So let's make a start with defining project resources. What is a project resource? Anyone or anything needed to complete the project. What are the types of project resources? Primarily three. Previously, they used to be referred to as 3M, man, material, and machinery. But nowadays, they are better referred to as human resources or team resources, physical resources, and financial resources. The human resources are the people who are required to complete the project. And they are also referred to as the project team. They themselves can be categorized into three: project staff. These are the people who actually produce the project deliverables. On a construction project, they will be the masons, the bricklayers, the carpenters, the steel workers, the plumbers, the electricians, welders, painters, etc. Then there is the project management team. Project management team members manage and supervise the project. Depending upon the size of the project, they will be the managers for different project areas like scope, schedule, cost, quality, etc. So there could be a quality manager, a finance manager, a risk manager, a schedule manager, etc. By the way, project team, project staff are referred to as the blue-collar people, and the project management team are referred to as the white-collar people. The third category is that of contingent workers. These are temporary workers who join the project for a brief spell of time to serve a specific purpose, like to install a plant or to commission a plant. And after they have finished their job, they leave. Likewise, contractors teams, consultants also fall into this category. So project team primarily consists of project staff, project management team, and contingent workers. Coming to the physical resources, these include equipment, machinery, tools, materials, facilities, technical resources, infrastructure, superstructures, supplies, etc. On a construction project, these will include building materials, like cement, aggregate, bricks, blocks, etc. Machines such as excavators, bulldozers, lifts, concrete mixers, pumps, motors, etc. Tools like carpentry tools, plumbing tools, flooring tools, etc. And the services like water, electrical power, etc. Finally, there are the financial resources, a subject which we have already discussed under controlling project costs, which was MEC 5. Now let us turn our attention to understand what controlling resources mean. Controlling resources basically have two prongs. The first prong suggests that the project must be given the resources which have been planned for that project or which are required for that project. And the second prong is that resources which are not needed for the project should not be allocated to the project, or the project team members should not ask for those resources which are not needed for the project. So basically, two prongs. The first prong suggests we must have the resources in the right amount, at the right time, and at the right place. Whereas the prong two suggests that there should not be wastage of resources. When you allocate resources to a project which are not required to the project, de facto, you're wasting the resource. So must have and must not have. These 2 points are further embodied in different concepts, like the concept of JIT. Just in time refers to this element of the first prong. That means to have the resources at the right time. Then there is the concept of JEJIT, J-E-J-I-T. J-E stands for just enough, which is this element in the right amount of this prong, and JIT, just in time, that means this element of this prong, must have prong. Then are the concepts of lean and the Japanese concepts of Muda, Mura, and Muri, which we will discuss now. Lean is basically efficient use of resources. And how do we achieve that? That is achieved by eliminating wastage of resources. There can be 3 deviations or violations of this principle, which are elaborated by the 3 Japanese concepts, which I referred to earlier. The first concept is Muda. Muda is plain wastefulness of resources, or adding or using resources on the project without getting corresponding value. This is further elaborated by the law of diminishing returns. There is usually a misplaced perception amongst project team members that more the resources you dump, the gain in time would be proportional. That means if you double the number of resources, then the time would be cut in half. If you quadruple the number of resources, the time required to complete the project would reduce to 1/4. This is dispelled by the law of diminishing return. For example, let us say that there are X men required to complete an activity, and they will complete this activity in Y hours. Then by the principle of human effort, we always multiply the number of men with the number of hours required. So the man hours effort required to complete this activity is X multiplied by Y. Let us say this activity actually requires 12 man hours to complete. Then X, Y is equal to 12. And if we now reformat this equation into its independent and dependent variable, we get Y is equal to 12 upon X, where X is the independent variable and Y is the dependent variable. What is important to note is that the relationship between Y and X is not directly proportional, but inversely proportional or reciprocal. This will soon become clear if we actually draw a graph now. We have the independent variable along the x-axis, which is the number of men required to complete the job, and on the vertical axis, the amount of time they will take. If we employ one person on this activity, then because xy is equal to 12, one person means he will complete the job in 12 hours. If we increase the number of people by 2, that means we double the number of people employed on this activity, then by this equation, xy is equal to 12. So y is equal to 12 upon x, which is 12 upon 2, we get 6. So 6 hours are required to complete this. If we employ 3, it will require 4. If we employ 4, we'll require 3, and we can continue going to the right. we now draw a smooth curve through these points, we find that it is not a straight line. And that is the essence of the law of diminishing returns. Let us analyze it a bit. When we increase the number of people working on this activity from 1 to 2, we gain 6 hours. But when we increase the number from 2 to 3, the increase is only 2 hours. And when we increase from 3 to 4, the increase is only 1 hour. Meaning thereby that as we are dumping more and more resources into this activity, the value we are getting is not proportional, not directly proportional. And in fact, in any case, if you look at this graph, the graph is flattening out after 3. That means there is no meaningful gain in value after 3, or the maximum number of people that you can employ on this activity to gain some reasonable value out of this increased manpower is perhaps 2 or 3, no more than that. Even this graph is rather too optimistic because in reality, because of logistic arrangements of accommodating so many people in a confined place, this graph would look something like this. In fact, it will flatten out even earlier. So if we employ more and more people on this activity, it will be Muda. It will just be wastage of resources. That is what the law of diminishing returns is, and that is what Muda is. Then there are other concepts. Mura. Mura means uneven distribution of resources or uneven use of resources. And then the concept of Muri, which is overburdening of resources. Perhaps these terms would become clear with one simple example. Let us say on a project, we have 6 one-ton pallets lying somewhere off-site. And these are to be transported to the project site. The resource available to the project manager is this 3-ton truck. That means its maximum permissible carrying capacity is 3 tons. Now, what will be the lean approach? What will be the efficient approach? Or what would be the common sense approach? Because the capacity of this truck is 3 tons, we have to transport 6 tons. It will be logical, it will be common sense that this truck makes 2 trips of 3 tons each. This way, the resources will be utilized optimally. There will be no wastage. There will be no uneven loading of the resources, and there will be no overburdening. In other words, what we are saying, there will be no Muda. That means there's no wastage, there's no Mura, there is no uneven loading. Both trucks are carrying the same amount, and there's no Mura, no truck is being overburdened. In fact, this is what lean is, efficient use of resources. However, if the project manager or the transport manager decides to transport these 6 pallets in 3 trips, for reasons, there could be many reasons like overtime, etc. Then obviously we are wasting 1 trip. That is Muda. On the other hand, if we make the first trip with just 2 pallets and then suddenly realizing that we must transport it in 2 trips, otherwise we will have a lot of explanation to give to the project manager or program manager or whosoever is supervising. And therefore, we overload the second trip with 4 pallets. This is uneven distribution of load on the 2 resources. This even exceeds the maximum permissible. And then if we decide to save on the trips and do it in just 1 trip, thereby saving a lot of time and money, by putting all the load on the truck, that is all 6 tons, it may be possible to do it. But what is happening in the process? Because we are overloading this truck, we are overloading it by twice really the maximum permissible load. We will most probably break its axles. And because the axle load is much higher than permissible load, it will also rut the road. It is going to ruin the road on which it is going to travel. So this is Muri. Muda, Mura, and Muri. These must be avoided if we have to achieve lean utilization of resources, that means optimum utilization of resources. So these are 3 simple but beautiful Japanese concept of, resource control. Let's return to controlling resources. So we have discussed what JIT is, what JEJIT is, what lean is, what Muda is, and of course, what Mura and Muri are. The other points of consideration in controlling resources is that whatever we had planned by way of allocation of resources should now be compared with actual utilization of resources. And we have already done this exercise as part of variance analysis. If you recall material usage variance and labor efficiency variances, those variances or those KPIs were nothing but a comparison with planned allocation versus the actual allocation and utilization of resources. The next point is that resources must be released when no longer required. Now, this is particularly true in functional organizations. In functional organizations, project teams are made up by borrowing resources from different departments. The general practice is that the project managers usually want to hang on to those resources till the project is complete. Why? Because they fear that they may not get the resources back from their parent departments should a need arise. Likewise, the resources also don't want to return to their parent departments. Why? Because now that their work is complete, it is perhaps easy time for them on the project. And secondly, when employed on the project, the resources get, at least in public sector projects, what is called the project allowance. And that is a hefty amount, amounting to almost 50% extra pay. So for these 2 reasons, neither the resources want to return, nor the project managers want to dispense with these resources once they are no longer needed. But this is against the project management practices. So please return the resources if they are no longer required. And then controlling resources is an exercise which is carried out continuously and throughout the project lifecycle. Now, let us see what sort of methods or tools and techniques can be used to control project resources. There are, of course, some data analysis techniques like alternative analysis, cost-benefit analysis. We're going to do them now. Multi-criteria decision analysis techniques like AHP. AHP is something which you did in the last semester as part of your risk course, so I'm not going to repeat it. TOPSIS, etc. Performance reviews and trend analysis. Then, of course, we have PMISs like Primavera, like MS project, and again, you have done that already in your previous semester when you did MS project. You actually did a project, you allocated resources in that project, and you perhaps went through the exercise of monitoring and controlling those resources. So I'm not going to revisit that. These two aspects, conflict resolution and interpersonal and team skills, pertain to human resources, and this I will deal with in part 2 of this subject. So let's start with data analysis. The first data analysis technique is alternative analysis. As the name suggests, for a particular problem, there are multiple solutions. There are alternative solutions. And you have to pick up the best possible solution or option. How do you do that? Let's take an example. Your project is getting late. And obviously, as project manager, you are concerned. What are the options available to you? Well, the first option is, let it be late. The only thing is that you will be defaulting on contract, so be it. What is the implication? That you may incur liquidated damages. You are so quality conscious that you are not going to cut corners. If the project is late, it is late for some reason. And therefore, you are not going to compromise on quality in order to gain time. Yes, in the process, you will pay the penalty of liquidated damages. Option 2 is that your concern is your reputation in the industry, that you are a project manager who always delivers on time. So you must maintain that reputation by ensuring timely delivery to the customer. So what you do, you exercise some schedule compression techniques like fast tracking, like crashing, like going multiple shifts, like going into overtime, etc., etc. So these are the two options available to you. You obviously brainstorm, you think about it objectively, you think about it subjectively, and then you decide whether to go ahead with option 1 or option 2. This is an alternative analysis in very simple form. But a more sophisticated form of alternative analysis is the cost-benefit analysis. So let's look at cost-benefit analysis. In cost-benefit analysis, for each option, for each alternative option, the strengths and weaknesses are assessed, are weighed. And then again, through brainstorming, through collective wisdom, you decide whether the strengths outweigh weaknesses or vice versa, and decide on the option. In control actions, Corrective and preventive actions, again, may have multiple options. So which corrective action or which preventive action you would go for? Again, you can do a cost-benefit analysis and decide on the optimum option. If the costs and benefits of the options can be quantified, then the best thing to do is go for a statistical approach. What you see on the screen is a simple graph, benefits along the x-axis, costs along the vertical axis. And then you see this diagonal line. On this diagonal line, costs are equal to benefits. That means if you invest 1 rupee, you get a return of 1 rupee. Above this line, the costs are more than the benefits. And below this line, benefits are more than the costs. So your first endeavor should be, when you are looking at options, you plot those options and see which options fall below this line. Those are the options which should interest you. Should there be more than one option below the line or even above the line, you look at cost-benefit ratio. Cost-benefit ratio, that means the ratio between cost and benefit. In cost-benefit ratio, usually the cost is taken as 1 and the benefit is indexed to the cost. So a cost-benefit ratio of 1:1 would mean that the cost is 1 and the benefit you accrue from this particular option is also 1. If the cost-benefit ratio is 1 to something less than 1, that means for every 1 monetary unit you invest, you are getting less than that in benefit. And similarly, if it is more, then you are getting more than 1 in benefit. Perhaps a simple example would further illustrate this. In this case, a project manager has 5 options. These could be the options for corrective actions. These could be options for a workaround, or could be anything. These are on the table and he has plotted them. Immediately, all the options which are above this line can be discarded because those options, the costs outweigh the benefits. That leaves these 2 options, B and D. In B, the cost-benefit ratio is 1:1.45, and in D, it is 1:1.39. What does that mean? That with D, if you invest 1, you get a return of 1.39, or in other words, if you invest 100, you get a return of 139, or the benefit is 139% of the cost. And in this case, the benefit is 145% of the cost. Clearly, this is a better option. Let us take a very simple example from real life. There is a gentleman whose business is real estate. He buys a plot of land, he builds a house on that, and then he sells that house, something which is very common. He has now purchased a 1 canal plot, and he has 2 options, whether or not to go for basement. So his option A is ground floor plus first floor with no basement, and option B is ground floor plus first floor plus basement. He has the following data. He purchased the plot for 1 crore rupees. If he goes without basement, he will be spending 1.5 crores on construction costs. That is option A. With basement, he expects to incur a cost of 2.5 crores. Without basement, the project will be complete in 12 months. With basement, 15 months. And when it comes to selling the house, he hopes to sell the house for 3.5 crores if it is without basement and 5 crores if it is with basement. So let's do cost benefit analysis. In option A, the total cost is the cost of the plot, which is 1 crore, plus the construction cost, which is 1.5, making it 2.5 crores. He hopes to sell this, that means the benefit or the value of this proposal is 3.5. That means he should be able to sell it for 3.5. Now we can divide benefits by costs and we get a figure of 1.40 or a cost benefit ratio of 1:1.40. That means he is likely to earn a profit of 140%. Sorry, not 140%, 40%. And likewise, for option B, the cost of plot obviously remains the same, 1 crore, construction cost 2.5, total cost 3.5, and he hopes to sell it for 5 crores. So 5 divided by 3.5 is 1.43, or the cost benefit ratio is 1:1.43. So looking at the two ratios, he should go for option B. That means he should go for the basement. He will earn more, or this option B is more beneficial to him. However, if he is in a hurry, he has to complete this project and then he must return to his second home in Europe or in America within a year, then obviously option B, despite being better, is no good for him. So whenever there's a constraint, you have to see the best option in the context of that constraint. And in this particular case, the best option is constrained by the duration he can afford for this project. And therefore, because of this constraint, he should go for option A. If time is not the constraint, B is the better option. So that is a very simple but real life example of cost benefit analysis. Next, we move to other data analysis techniques. The first one is the performance review. Well, performance review is nothing but a sort of variance analysis. What do we do in performance review? We review what we had planned and what we have achieved. How many resources we had planned and how many resources we have utilized. And a simple comparison between the two is a performance. This is, as I said earlier, is variance analysis, something which we have already done. By the way, performance review is, or it applies to resources, utilization in performance of work. It refers to utilization of resources. It could be human resources, it could be physical resources. It does not apply to performance of employees. This may give the impression in performance review that we are measuring the performance of employees. No, we are assessing the utilization of resources or comparing the utilization of resources with what we had planned. So performance review has nothing to do with performance appraisal or performance evaluation or employee appraisal or confidential reports, performance reports, etc. Next, we come to trend analysis. Trend analysis, in trend analysis, we take the existing data and project it into the future to see how the things are going to shape up in the future. For example, it is summertime or late summertime, and the first slab of the construction project has been poured. When it comes to machinery resources, it took one mixer and one lift. So that was enough. And the whole process took 12 hours to complete. So 12 hours with one mixer and one lift. Let us say it is now time to pour the second slab, but now it is winters. It is December. Days are short. If you continue with one concrete mixer and one lift, it will take you 12 hours, but then that 12 hours will push you into night, and you don't want to do that. So based on this existing data, you say, okay, I want to complete this concreting within 6 hours, 8 hours. So I will have two concrete mixers and two lifts. So we have used existing data to see the shape of things in the future and modifying our plans accordingly. This is what trend analysis is. On that note, we end part 1 and see you in part 2. Thank you.